Hello and welcome. This is Camille Fairborn from Michigan State University, and I'd like to welcome you to today's CAUSE Teaching and Learning webinar. I'm pleased to introduce today Brian Gaines as our presenter. He is a research statistician developer at SAS. For today's webinar, he will give a presentation entitled Teaching Data Science with SAS University Edition and JupyterLab. The way the webinars work is that all listeners are muted during the webinar. You can ask questions at any time by typing them into the questions box. We'll be sure to ask those questions towards the end and give our presenter a chance to respond. You can also use the chat box if you are having any technical questions. So at this point, I'll turn things over to our presenter. Brian, go ahead.
All right, well, thank you, Camille. And I'd also like to thank CAUSE for organizing the webinar. I'm definitely excited about the opportunity to talk to everyone today. So to begin my talk, I would like for you to think back to a time when you conducted some sort of data analysis and you needed to communicate your results in writing. This could have been a journal article or a blog post for a website or just any sort of analytical report for a client or a boss or a collaborator. Logistically, this involves combining explanatory text and maybe some math notation with the results and possibly some code from SAS. In doing so, I assume that many of you are like me in that you perform the data analysis in one program, and then you have to export the results to another program where they are then integrated with your write-up. Often this process involves painstakingly copying and pasting your code, output, and graphs from SAS to a word processor such as Microsoft Word. In addition to being tedious and prone to errors, this approach makes it challenging to update your report if you tweak your analysis, and it makes it difficult for other people to reproduce your results. Alternatively, you could use a typesetting program such as LaTeX to automate some of this, but that requires some extra time and setup at the beginning, and personally, I find myself unwilling to do so. So as an example, here's a snapshot of one such report. Now, you definitely do not need to read everything here. This is just designed to be representative of the kind of report I'm talking about. So you can see that there's some math notation that's specifying the model. We have some explanatory text, and then we also have some results that were generated by SAS. Now, suppose you send this report to your boss, and she says, wow, that looks great. Your new model is doing a lot better than what we're currently using in production. But what would happen if you change the classification cutoff to 0.55? Or what would happen if you removed a certain predictor variable from your model? Well, for this, you would have to go back, find all of your original SAS code files, incorporate her suggestions, rerun the analysis to get the updated results, take those results, and then insert them back into the original report, update that before you're finally able to send that off to your boss. Well, what if I told you that there is a better way? What if I told you that there is a workflow in which your executable code, your results, your descriptive text, and your math notation could all seamlessly coexist in just one document? This workflow is made possible by Jupyter Notebooks and the JupyterLab application, and that's what I would like to talk to you about today. So to give you a little preview, let's look back at that report, that example report that I just showed you, except now it was created as a Jupyter Notebook. In this document, you can see that the code appears right alongside the explanatory text and that the results generated by that code appear directly below it. Now, if you wanted to update this report to incorporate some of your boss's suggestions, you would just need to execute all of the code above this block, come down to this line, change the classification cutoff value to that new value of 0.55, execute this code, and then the updated results would appear directly below. There's no need to copy and paste anything, and there's no need to use multiple programs. Not only does this workflow boost your productivity in the long run, but perhaps best of all, it's free and easy to use. So now before I dive right into JupyterLab, I first want to take a step back and make sure that everyone is aware of the many free resources available to educators for the sake of using SAS for teaching and learning data science. If this slide looks a little like information overload, that was actually done by design to highlight the fact that we have a ton of resources available to educators, and I highly encourage you to take advantage of them. One of my colleagues from the academic outreach group here at SAS has joined me for today's webinar. So if you have any questions about these resources, she'll be available later to say a few words and then to also answer any questions during the Q&A portion. Today, my focus is going to be on one of the free software offerings, SAS University Edition, which you can download for free by going to sas.com/academic. This is also the website that you can visit if you would like additional information about any of these resources. So SAS University Edition is a free version of select SAS products that runs on all three major operating systems, or you can also access it from AWS. Despite its name, it is not exclusively for current faculty and students, but it's really available to anyone who wants to learn and use SAS for academic non-commercial purposes. It includes the main products you need to perform advanced statistical analyses. One of the interfaces that comes with SAS University Edition is SAS Studio. SAS Studio is a modern browser-based SAS programming interface that is an alternative to the classic windowing environment and to Enterprise Guide. SAS Studio has a variety of nice features that can help you and your students learn SAS more efficiently. If you'd like any additional information on SAS Studio, if that's something you're not familiar with, then I would encourage you to either visit the SAS Studio product page or contact me after this presentation to learn more about it. SAS University Edition also includes the open source programming application Jupyter Lab, which is the successor to Jupyter Notebook. Both of these applications use Jupyter Notebooks as the primary document type and interface. So to be clear, when I'm referring to Jupyter Notebook with a capital N, that is the application that predates Jupyter Lab, whereas Jupyter Notebook with a lowercase n, that is the actual document type and coding interface that's common to both of those applications. The naming scheme is just a little confusing. Regardless, Jupyter Notebooks have become very popular in recent years, especially in the data science community, because they enable you to seamlessly interweave your executable code, your results, and your text into the same document. I should also mention that even though today my focus is on using Jupyter Lab with SAS University Edition, that it's also possible to do the same if you have a paid SAS license. So my motivation for talking to you about SAS University Edition and Jupyter Lab today is because together they form a great combination for teaching data science and statistics. As most of you are probably aware, in the past several years, we've witnessed this explosion in the availability of data and the demand for talent to analyze it. As a result, new programs in data science keep springing up, and there have also been calls for the existing academic programs in statistics to be updated to reflect these changing times. And so some of the recommendations, some of the themes to those recommendations include an increased emphasis on computing, communication, collaboration, and reproducibility. In my talk and in the companion paper that goes with it, I demonstrate how these points of emphasis can all be readily addressed using SAS University Edition with Jupyter Lab. Also, as a little bit of background on myself, before I joined SAS a few years ago, I did quite a bit of teaching in grad school, and I was actually very close to staying in academia as a teaching professor. So after I cover some of the basics of using Jupyter Lab, I will provide a couple of examples where I found it especially useful to use Jupyter Notebooks when I was teaching statistics courses with SAS. So without further ado, let's go ahead and take Jupyter Lab for a spin. So you first start up SAS University Edition in a virtual machine here, and then you access the main information center using your browser. Here you have the option of using SAS Studio, or you could also click to use Jupyter Lab instead. And when you click on the Start Jupyter Lab button, that's going to open up Jupyter Lab in a new browser tab. When you open up Jupyter Lab, on the left, you have this collapsible sidebar that initially displays a file browser. And then on the right, you have this main work area, which initially displays the Launcher tab. The Launcher tab enables you to open up a new notebook that uses one of the available programming languages through an analytical engine called a kernel. The SAS kernel is an open source project from SAS that's available on GitHub, and it's actually the main piece that you need if you want to use SAS with a paid SAS license with Jupyter Notebooks. SAS University Edition also comes with the Python 3 kernel in addition to the SAS.py module. The SAS.py module is another open source project by SAS that enables you to access and call SAS while you're coding natively in Python. So let's go ahead and click SAS to open a notebook that uses the SAS kernel. So a notebook consists of these different blocks that are called cells, and that's what you see here. And by default, these cells enable you to execute and submit code to using the programming language or the kernel that you selected. So in other words, you can go ahead and just start typing your code like you normally would in any other interface. So as an example, let's suppose that you want to display the contents of the class dataset that's located in the SAS help library. For that, I would just go ahead and type the proc print code like I normally would. I'd press Control plus Enter. That's going to be submitted to SAS and executed by SAS, and then the results are going to display directly below it right here in my notebook. You can add additional cells into a notebook by using this plus button on the notebook toolbar. So let's go ahead and do that. With the notebook toolbar, there's also this drop-down menu that enables you to change the type of the cell, and markdown cells are the other primary type that you're likely going to be using. So let's go ahead and select that. Markdown is a simple but effective syntax that enables you to incorporate text and math notation and common text formatting into a Jupyter notebook. So as an example, the pound symbol is the markdown syntax for a section heading. So if I specify that, and then if I give my section a name, again, like before, hit Control plus Enter, and then the text is going to render with the formatting that you specified. You can also include math notation into your notebook by enclosing the appropriate syntax in $signs. So if you've used either LaTeX or MathJax in terms of specifying math notation there, this is going to essentially use the same type of syntax as that. So as an example, if you wanted to specify the model that you used in your analysis, you can do that with the appropriate syntax. Let's see if I can spell epsilon correctly. And then just like before, if you press Control plus Enter, the math notation is going to render with the symbols that you specified. So these two types of cells, the code cells with the corresponding output, and then the markdown cells with the formatted text, these two cells are really the fundamental building blocks of a Jupyter notebook that you can combine really in an infinite number of ways to slowly build up and create your analytical notebook. So right now I've just showed you some of these, the basics of Jupyter notebooks, and what I've shown you so far isn't actually new to Jupyter Lab specifically. This is just basic functionality that's been around for a while. Jupyter Lab did include some initial additional features and improvements to the Jupyter Notebook interface, which I discuss more in my paper. For now, I'd like to just discuss a few things, some of the new features and functionality that's available in the broader Jupyter Lab interface. So Jupyter Lab essentially takes several of the elements that were available in its predecessor and it combines them all under the same roof. So they are now all within one browser tab as opposed to being spread across multiple tabs or multiple windows. So as an example, if you were to double click in the file browser to open up a new notebook, you see that that notebook is going to appear as a new tab in the work area as opposed to a new browser tab or in a separate window or anything. Jupyter Lab also added additional support for additional file types such as PDF and CSV. So if you had a data set that was in CSV format and you wanted to view your data file, if you double click on that, you can see that that CSV file is going to open up right here within Jupyter Lab. You don't have to use another program such as Google Sheets or Microsoft Excel or anything. Jupyter Lab also gives you the flexibility to rearrange and resize the different tabs that you have in your main work area. So as an example, if I take this train CSV tab corresponding to the data set and I drag this to the bottom, you can see that now I'm able to view my notebook and my data set at the same time. Similarly, if I were to drag this tab over here, I can now view both of these notebooks simultaneously. All right, so that's essentially the basics of Jupyter Notebooks and also some of the other features available in Jupyter Labs. So now let's look at some of the ways in which using Jupyter Notebooks can be really beneficial when you are teaching data science. And so this first example I have is a homework assignment on data management and pre-processing. And one of the reasons I chose this example specifically is because you often hear that much of a data scientist's time is devoted to cleaning and managing data. So these types of data wrangling skills are important for your students to develop. The original inspiration for this example is from one of the courses I used to teach. And in that course, there is a weekly lab section where students were in a computer lab and they were able to get hands-on experience using SAS with the assistance of a teaching assistant. And originally these lab assignments and homeworks were created in Microsoft Word, which involved a lot of copying and pasting, both for myself and for my students. And so I thought that this was something that was really a perfect candidate to be done as a Jupyter Notebook instead. And so now when you would give this assignment to your students, just like before, you have some background text, some instructions, you include maybe some starter code, but instead of the student first having to immediately take this code and copy and paste it into another program, they can just go ahead and execute it. But because this is, instead of just this static Word document, this is more of a living dynamic document. And then as the student would scroll down and look at the questions, again, they could answer these questions directly in here using whatever combination of markdown cells and code cells that they needed to adequately address the questions. And so I thought that this was nice because not only did this really kind of improve the workflow and the user experience for my students, but it also gave them practice communicating the results of analysis while using this commonly used tool in Jupyter Notebooks. Jupyter Notebooks also make it easy for you to share your analysis with others for the sake of both reproducibility and collaboration. So for example, one of the things I started doing in my classes, and I've noticed that a lot of other people are doing this more frequently nowadays, is that I required my students to submit their homeworks electronically as a Jupyter Notebook using GitHub. And part of the reason I did this was because just simply having knowledge of a version control system such as Git in and of itself is useful for a data scientist, but I thought it also made it easier for me or a TA to go through and grade the homework because now everything was in one document. It was a lot easier to follow along and potentially submit code if there was maybe an error, if we needed to check something, check some of the students' work. And so that in and of itself was beneficial. Another nice thing about using Git is that when you use a Git hosting service, such as either GitHub or GitLab or Bitbucket, that the notebook itself is automatically rendered when you view the notebook file from the hosting service's website. So to see that, here is a copy of the completed version of the homework assignment that I just showed you, and I'm now viewing it from GitHub. So I'm within this SAS School of Form 2019 GitHub repository, and I'm also just viewing the notebook file itself. This file with the .ipynb extension, and instead of viewing the guts or the JSON or HTML that goes with the underlying notebook file, you're able to just view it here in a human readable form. You don't have to actually go through and download this and open it up in Jupyter or anything. While I'm here, I should note that so within this repository, there's a directory with my name in it, and then if you go to that directory, that all of the notebook files and the data sets that go with my companion paper, that those are all available to anyone. So really anyone can download SAS University Edition for free, and then they can go get these notebook files to hopefully jumpstart with playing around with Jupyter Lab. Another way that you can share your notebook files is to first export it as an HTML file and then distribute it that way. So for this, you would go to File, then Export Notebook As, and then click Export Notebook as HTML. Once you do that, it'll take a few seconds to compile the document and download it. And then once you have it, you can go ahead and open it up. And so this is, again, is a nice way to share a notebook file, because if you send it to someone who may not have a Jupyter interface installed, this is a way for them to still easily view that in a rendered human readable form. All right, so that is my first example. And then as another example, another situation where I found it especially useful to use Jupyter Notebooks when I was teaching was for the creation of lecture notes. And so one of the reasons I like this was kind of selfishly, I liked it because now I, as the instructor, really benefited from this streamlined workflow, and it really made it a lot easier for me to update my lecture note examples over time, since everything was just all incorporated into this just one document. And I also particularly like to distribute my lecture notes before class so that students would ideally be able to follow along during class and submit the code along the way as I was going through the notes. And specifically, I would at some point ask my students, there'd be usually a certain type of a block of code that I would ask my students to execute. And in this example, they were asked to construct a bootstrap confidence interval that uses a random number seed based on his or her birthday. And so they were asked to, they would first execute this code. They would then talk about the results in a small group, just basic things such as, did you guys get different intervals? Is it okay that you got it different intervals? What happens to the length of the interval once the number of bootstrap samples changes, those sorts of things. So just trying to hit at those important concepts of sampling variability and randomization. And once the students talked about those as a group, then we would have that would lead to a larger discussion as a class. And so using Jupyter Notebooks in this way facilitated the use of active learning, in which your students are actively engaged in activities during class instead of just passively listening to a lecture. And as highlighted by a recent meta-analysis of over 200 studies, there's been a growing body of literature that suggests that active learning is a more effective teaching approach than traditional lecturing, especially when it comes to STEM fields. And so although for this example, there was an upfront cost to convert your existing lecture notes to Jupyter Notebooks, I felt that in the long run, it would be worth it, and that it was also something that would be a good job for a teaching assistant to help out with. Then another reason I actually chose this example specifically is because I think that randomization methods such as permutation tests and the Bootstrap are very powerful tools that should be in every data scientist toolkit. There's also been some evidence that students who are taught using these methods can actually better grasp important statistical concepts. Tim Hesterberg from Google has a great article on this, which I cite in my paper if you're not familiar with that. And so with that, I will go ahead and start wrapping up. So as I was hopefully able to demonstrate to you, SAS University Edition and Jupyter Lab form a great team when it comes to teaching data science and modern statistics. Your students are able to learn these valuable SAS analytics skills while also becoming familiar with the popular Jupyter Lab interface. Not only does Jupyter Lab inherently have this improved workflow that will boost your productivity, but it also addresses some of the important aspects of training well-rounded data scientists. And then for now, I'm going to actually turn it over to my colleague, Cheryl Cass, who is in the Global Academic Programs group here at SAS. And again, they're the group that oversees the different academic outreach efforts and the resources that I mentioned earlier. So Cheryl, I'll turn it over to you.
Wonderful, Brian. Thank you so much. And thanks for inviting me today to share more with the audience about what our team does. So as Brian mentioned, I'm on a team called Academic Programs, and we're part of the larger education division here at SAS. So I wanted to talk to you today about what the mission of our team is, and it's really all about faculty enablement. So as Brian mentioned earlier in his presentation, we have a pretty large variety of resources for teaching and learning. And it's our goal as a team that we can provide support to faculty, enable them to deliver our tools in the classroom such that they can begin to train their own students to use our software. The ultimate goal in enabling faculty and training students is really that ultimately we want to connect students who have SaaS skill with our commercial customers who have analytics hiring needs. So, I'm fortunate that on our team, we have quite a bit of higher education experience ranging from former faculty members, university administrators, and PhD level statisticians. And with regard to the faculty resources for teaching and learning, I think probably one of the most important things that I haven't said yet is that it's all free. So everything that our team does with regard to faculty enablement and student training is free. So for example, we can come to your campus and we can deliver a faculty training workshop. We have plenty of free software. Of course, University Edition is included in that, but there are other platforms as well. We even have teaching kits that faculty can download and embed directly into their courses. And the teaching kits include things like PowerPoint slides and a PDF of course notes and all of the data sets that are needed in order to deliver that course. So the reason why I thought this slide was important to include is that the best way to get in touch with our team, if you're interested in taking advantage of our free academic resources, is to first go ahead and send an email to academic@sas.com. And so I know that sometimes it can be a little bit frustrating when you have this generic email address. And so really the purpose of this is to show you that when you do send an email to that email address, you'll be connected with one of the program managers that supports your region. So for example, if your institution resides in one of the green states listed on this map, then you'll be connected directly with me so I can help you through the process of using our free resources.
All right. Great, thanks a lot for that, Cheryl. And then again, I'll just leave up our contact information. One thing that I did want to note is that I have a link to my website here, and if you go there on the main page, there is a link to the paper that goes with my talk. In my paper, I do include a few additional tips and tricks for using Jupyter Notebooks with SAS, so I would encourage you to check that out. And on my website, there is also a link to the GitHub repository with the example notebooks and also the data to reproduce everything that's done in the paper. So again, really anyone can download SAS University Edition for free and also download my example notebooks and get up and running with Jupyter Lab. So with that, I think we'll open it up for questions.
All right, thank you, Brian and Cheryl, both of you for presenting this for us today. If any of you who are participating want to ask some questions, you can go to the questions bar and type your question in there, and I'll ask that to our presenters. I have a couple of them already. One's asking, are the SAS academic resources available to non-academic institutions, for example, the federal government research laboratories?
So there are a couple of reasons. Brian, do you mind if I jump on in here?
I was gonna say, yeah, please take that. I think that's right up your alley. Yep.
Sure, absolutely. So there are a couple of resources that you would still have access to. So for example, University Edition is something that is really free to all learners. So you can go to our website and do that. In addition, there are some things like e-learning. So not all of our e-learning is free, but if you were to just do a quick Google search for e-learning in SAS, you would come to a website that basically shows you all of the e-learning modules that are free and open to the public. So some of them, but not all of them.
All right, and then another question is Jupyter Lab available in SAS on demand for academics?
That I'm pretty sure that it is not available. So I think it's like if you have SAS University Edition, it comes with it, and then like I said, if you have a paid SAS license, you can get it. But I don't think it's currently bundled or available with the on-demand for academics. But that's a good point that I'll bring up with the product manager of that area to see if something like that would be possible.
Okay. Well, it doesn't look like we have any other questions. So again, thanks to both of you for presenting to us today, and thanks to all of you who've come to listen and participate. And we will probably see you on the new year with new webinars coming up. I know there's several on slate for the spring semester. And until then, I hope everyone has a very nice holiday season and a successful end of the semester.
Yeah, thank you. Happy Thanksgiving.
You too.